Okay, if I have 1/2 plus 3/4, I'm going to find the common denominator, which is 4. I change my 2 into a 4 by multiplying by 2. And then anything I do to the denominator, I'm getting some kind of feedback, so I'm going to mute you. Perfect. Okay. And then now that I changed my denominators, how did I change my 4 into a 4? I multiplied by 1. Anything I do to the denominator, I do to the numerator. And then my 2 to a 4, I multiply it by 2. Anything I do to the denominator, I do to the numerator. This becomes 2/4. This becomes 3/4. Now that I have the same denominator, I keep my denominators 4. I add my numerators 5/4. And then 2 plus 3, my last step would be to do 5. Now, this is an improper fraction, so to change my improper fraction to a mixed number, I basically say, how many times does 4 go into 5? 1. What's my remainder? 1. So it's 1 and 1/4, and I'm going to add that to my 5. So it's 6 and 1/4. To multiply fractions, I do 2/3 times 5/6, and I would just multiply across and simplify. But because we're now in 6th grade, we're going to do 2 and 2/3 and 3 and 5/6. So we're working with bigger numbers. 2 and 2/3 is going to simplify. We're going to change it into an improper fraction. 3 times 2 is 6, 7, 8. 8/3 times 3 times 6 is 18, plus 5 is 23/6. We talked last time, just briefly, we just started it, about cross cancellation to simplify. So we're going to find out if any of these numbers right here, when we go diagonally, if any of them have anything in common. And if they have something in common that they can be divided by, then we're going to use that to simplify our fraction. So an 8 and a 6 has a 2 in common. So I am going to divide this by 2, and I'm going to divide this by 2. This would become a 4, and this would become a 3. And then 3 and 23, they have nothing in common. So that's as far as I can take it. So I'm going to use what I simplified. 4 times 23 is 92. And then 3 times 3 is 9. Now, because it's an improper fraction, I am going to change it to a mixed number. So 9 goes into 90 10 times. 10 times 9 is 90. 2 left over. So my fraction would be whole number 10. My remainder is 2. That becomes my numerator, and my denominator stays the same. And then I'm just going to check, can 2/9 be simplified anymore, just in case I made an error? No, they have nothing in common except for 1. Okay, we are going to do division of fractions, and we're going to just use a mixed number like this. So let's change it to a mixed number, from a mixed number to an improper fraction. 6 times 4 is 24, plus 5 is 29/6, divided by 3 times 1 plus 2 is 5/3. Okay, so we know the steps for dividing fractions are rewrite the first fraction, change my division to a multiplication, and flip my second fraction. Okay. We can just multiply across and simplify, but we're going to practice using that other simplifying technique where we use our diagonals to see, can we make this lower? And in this one, it's really going to help us because 3 and 6 have something in common. They can both be divided by 3. So you're basically going to divide both of these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And now we're just going to multiply across. 29 times 1 is 29, and 2 times 5 is 10. Now we're going to simplify. This is an improper fraction, so we are going to make it into a mixed number. 10 goes into 29 2 times. 2 times 10 is 20. 9 is left over, so it's 2 and 9/10. And then we're just going to make sure, can 9/10 go any lower? No, because they have nothing in common. Okay, our next thing is changing percents and decimals and fractions to each other. So these are all equivalent. 35% is the same as 0.35, and that's the same as 35 over 100. So to change a percent to a decimal, we take our percent sign and we make it into a decimal, and then we move the decimal over 2 spots and it becomes 0.35. To change my decimal into a percent, I do the exact opposite. I take my decimal and I go 2 over to the right, and my 0.35 becomes 35%. Now to change a fraction into a percent, if it's over 100, all you do is rewrite the numerator and add a percent sign. So if it's not, suppose it was 3/4, the easiest way to make it into a percent is try to make it into a 100 for the denominator. So what would I have to multiply 4 by to get to 100? I would have to multiply it by 25, and then I do that to the denominator, I do it to the numerator, and it becomes 75 over 100. And then we know 75 over 100, we would just do 0.75 and then move it over 75%. Sometimes it doesn't work out that simply, so let's use 2 7s. So 7 is never going to become a 100. So in this case, we can't get it to 100. So we're going to take the denominator and put it right here, and we're going to put the numerator right here. So for this case, it is the denominator is 7 and the numerator is 2. And now we're just going to divide it out. How many times does 7 go into 2? It doesn't. So we put our decimal right here and we add a 0. 7 goes into 20 2 times. 2 times 7 is 14. 20 minus 14 is 6. And we keep adding zeros until we clear it out, or we get a repeating decimal, which means it could be like 2.233333, and then we wouldn't have to keep going. So some of them clear, some of them don't clear. So 7 goes into 60. 8 times, it's 56. And then we have a remainder of 4. We add another 0. 7 goes into 45 times. It's 35. And we can keep going. But I know almost always all I have to do is go 3 digits in from my decimal, because most of the time I'm going to round to the hundredths place. And the directions will say round to the nearest hundredth. So now I'm going to round. I'm going to go to the neighbor. If I'm rounding to hundredths, I am going to underline what I'm rounding to, and then I'm going to go to the neighbor and say 4 or less, let it rest. 5 or more, let it soar. This is a 5 or more, so this is the number that soars, and it becomes 0.29. So those are a few examples. We have other examples like 2/10. What would that become? In this case, we can either change it to a 100 and it becomes 20, or we can just use this technique, which is what I always do. If it's a tenths, I know that this digit right after the decimal is a tenths spot. So I am just going to put the numerator right there, and this is 2/10. And I know that because whatever number, suppose I had 0.2653, this is the tenths, this is the hundredths, this is the thousandths, and this is the 10,000. So that's going to be what my denominator becomes, and my numerator is just going to be this number right here goes here. And then I count out what digit did this decimal end in. It ended in the 10,000ths place, and that would give me my denominator. Really quickly, because we might have summer brain, we're just going to go over multiplication facts, the ones that are a little trickier. So we're just going to do 7 times 6 is 42. 6 times 8 is 48. 7 times 7 is our football team, 49ers. 8 times 8 is 64. 8 times 4 is 32. 8 times 5 is 40. 7 times 5 is 35. And then we have 11 times 11 is 121. 11 times 10 is 110. 8 times 3 is 24. 6 times 4 is 24. 6 times 3 is 18. And 6 times 6 is 36. 5 times 5 is 25. And I think those are the ones that are the ones most people get a little hung up on. 7 times 3 is 21, and 7 times 4 is 28. So that will be a good review, just in case you have summer brain where you're a little bit slower, like, ooh, I forgot what those are. Okay. Next thing we're going to do is multi-digit multiplication. 356 times 28. Super easy. We just do ones times ones, 48. 8 times 5 is 40, plus 4 is 44. 8 times 3 is 24. 25, 26, 27, 28. Now we cross these out and we add our 0. 2 times 6 is 12. 5 times 2 is 10, plus 1 is 11. 2 times 3 is 6, plus 1 is 7. Now, in 6th grade, you might actually have longer digits. So it's the same exact process. It's just a little more to take care of. So you got to keep track. So suppose you had 1,356 times 328. You'll see that there's going to be a lot more to manage because you have one more digit here and you have one more digit here. So I'll just do a quick example. 6 times 8 is 48. 8 times 5 is 40, plus 4 is 44. 8 times 3 is 24, plus 4 is 28. 8 times 1 is 8, plus 2 is 10.
Can you hear me, Anne?
I can.
Oh, okay.
Is that the other computer?
Yeah, I'm on the other computer. Okay, I'm going to mute myself.
Okay, perfect. It worked. I love when that happens. It just fixes itself. 6 times 2 is 12, so we're going to put the 1 here and the 2 here. 5 times 2 is 10, plus 1 is 11. 3 times 2 is 6, plus 1 is 7. 2 times 1 is 2. Now for this digit right here, what I like to do at this point is I like to erase all of this just because it starts to get a little muddy looking and I like it to look clean so I don't get confused. You can cross the other row out and keep going, but I kind of ran out of room, so your preference. For this third digit right here, I am going to add 2 zeros as my placeholder, and then I'm just going to do the same thing. 3 times 6 is 18. 3 times 5 is 15, plus 1 is 16. 3 times 3 is 9, plus 1 is 10. 3 times 1 is 3, plus 1 is 4. So you can see it's a lot more to keep track of. If it starts to get a little bit off where you're not completely lined up, you can actually make these lines just to make sure. We don't want to do all of that work and then have it be misaligned and then you're getting it wrong because it's just not lined up because you did a lot of work here. So you can absolutely do this, and this makes sure to keep everything in the exact place value that it's supposed to be in. So now we do 8 plus 0 is 8, 4 plus 2 is 6, 8 plus 1 plus 8 is 17. I put the 7 there. I put the 1 here. 7 plus 6 is 13, plus 1 is 14. I put the 4 here, and I put the 1 here. 2 plus 1 is 4, and then 4 plus 0 is 4. So the answer is 444,768, and my comma goes 3 digits in, comma. If there were more digits, I'd put a comma here. So every 3 digits, we get a comma. The last thing I'm going to put on the video is multi-digit division. So for multi-digit division in 6th grade, you might have 2 or 3 digits here, whereas before we were pretty much just working with 1 digit. So it does get more complicated, but it's the same exact process. So we do the daddy, mommy, sister, brother, dog division, then we multiply, then we subtract, and then we bring down. It's just we're working with bigger numbers. So if I had 53 and then I was dividing 8, 2, 5, 6, 3, you can see it's way more digits to manage, but we still just keep doing the same exact process as we did all last year. And this is really important to keep everything neat and lined up, or you start to get confused because they are more complicated problems. Guess, Shree.
What is the brother and dog for?
Bring down.
Oh.
Remember that? We did it so last year. So the division is D, daddy. Mommy is multiplication. Subtraction is sister. And then brother, dog is bring that number down. And then we go back up, division, multiplication, until we run out of numbers. So for this one, we're going to do 53 goes into 82 one time. 1 times 53 is 53. And then we're going to subtract, and we're going to do 12 minus 9, 3 is 9. 7 minus 5 is 2. And then we bring this down. And so it becomes, how many times does 295 go into 53? And so we're going to have to start to not just be able to see it necessarily. So we have to start working it out and saying, I don't know, maybe 4 times. I don't know, maybe 5 times. And you kind of just have to take a good guess at where you start. But I know that this is about 50 and this is about 300. So it's going to probably be about 5 times, maybe 6. And so I'm going to try to start with something that makes sense and not just start out with like 53 times 2, 53 times 3. So I'm going to try to make a guess about how many times does it go in. My guess is 53. So 53 times 5 is 15, and then it's 265. I know that I can't fit another 53 in there because I'm only 30 away. So I know I don't have to go up to 53 times 6 because that's far enough to go in. Okay, so now my remainder is 30. I'm going to bring down the 6, and I don't want to get confused of what I've brought down, which is why I actually show the arrow so that I know which number to grab next to bring down so I don't get confused. 53 goes into 306. Well, I know 50 times 6 is 30, so it's going to probably be about 6 times. 6 times 3 is 18. 6 times 5 is 31. Oh no, I went too far. So I know that my last number I tried is going to be the one that works. And so I forgot to do this part. So I forgot to do this part right here that it went in 5 times. Okay, so now we have 306. 6 minus 5 is 1. This turns into a 10. This turns into a 2. So 41 is my remainder. And then I bring this 3 down. And 53 goes into 413. So I know that the times 6 gave me 318. How many do I think are going to fit in there? I think I'm only going to be able to go up one more, but I'll see how close I get. 35, 37. Okay, so suppose I do this, and it's not going to happen in this case, but I'm just giving you an example. So suppose I do this and I didn't get 42. Suppose I got as my remainder 56. I know that my remainder can't be bigger than this number right here. So this number right here, if it's bigger than 56, then I know that I used the wrong number here and I can go one more. But for this one, it was perfect, so that didn't apply. But I always want to check that my remainder is smaller than my number that I'm dividing by. So my remainder would stay the same. I have nothing left to bring down now. So this is the remainder. And that's how you know when you've reached your remainder, you've run out of stuff to bring down. And so 155 times 53. I forgot to add something in there. Oh no. 563 divided by 55. 155. I don't know what I did. Okay, well, I did that wrong. So don't watch that part. We'll redo it on the next video. I don't know what I did.